Mela, l-impenġu vectors toħloq inna problema zaħira bl-accuracy. Għan ispiegalkom daqxejn. Jekk ħana għodu impenġuhom għanna bżon squared paper, per eżempju, okay? U squared paper, you are always limited by the size of the actual squares. Ġifri, jekk jena impenġi, I know this is not the best grid, but jekk jena impenġi vector illi huwa 3 boxes in length, that's fine. Alright? Dak irnexxieli nibdih eżatt, or rather waslu eżatt semmek, u nibdih eżatt, insomma, ma kommentix, imma nibdih eżatt minn fejn tibda l-grid. The problem is, illi jekk inti kollok situazzjoni fejn għandek force, jew any vector quantity, velocity, acceleration, whatever, illi ma tiġix to an actual value of daqs ta' square, per eżempju, għandek xi ħaġa, għandek bżonna 0 squares u nofs, jew 2.3, okay? You can't be accurate there, okay? 2.3 squares, għajn kif sa taħdem dik? 2.352, oh my god, problema, okay? So, with drawing of vectors, with having, or rather solving vectors diagrammatically, we'll always be limited by the accuracy of the grid, the inti għandek. So, we generally try to avoid that in physics, and there is another way of going about this. It would be through triangles and trigonometry. Dan huwa actually li ħanibdew nagħmlu issa. Alright, so this video will serve as an introduction for the remainder of this topic u kif actually ħankun qed naħdmu kemm f'intermediate physics u anke f'A-level physics. So, very quickly, jiena ktibtilkom xi ħaġa hekk, għattilkom adding vectors diagrammatically offers limited accuracy and ideally we obtain our answers through calculations. Calculations with right angled triangles only work when two vectors are perpendicular. Now this is very, very important here, all right? So calculations with right angled triangles only work when the two vectors are perpendicular. ħanaw da xej waħda xiridu nagħmlu u kif ħanġibuhom perpendicular ma' xulxin. The method of components translates diagonal vectors into two coplanar, in the same plane, perpendicular ones, which make our calculations easier. So what we will be doing is using this method of components. Okay? ħanaw da xej waħda xiruma components. So, ejn ikkonsidraw vapur b'żewġ tugboats. I took the liberty to draw these, I mean, fuq notes tagħkom li ħad id-download jawek fil-każ għandkom il-link fil-description ta' dal-videos. You can actually draw these ħanibda niddiskutu fuqhom. So, ejn ikkonsidraw vapur, diħel il-port u qed jinġibet minn daw iż-żewġ tugboats partikolari għandna l-ewwel tugboat illi qiegħda tagħmel a force along the y-axis, it-tieni tugboat qiegħda tagħmel a force along the x-axis. Jekk napplikaw il-parallelogram law għal dan, li nagħmlu huwa we draw guidelines, nikkopjaw fx hemm fuq u nikkopjaw fy hawnhekk u hemmhekk noħorġu li r-resultant sa jkun just a straight line from start to finish. So this would be the resultant. F'dak il-każ, Fy u Fx huma components of that resultant. These two forces make up the resultant, okay? Give us the result. So, f'dak il-każ, kemm Fy u Fx hemmhekk nirreferu għalihom bħala components. Issa f'dan il-każ il-components huma 90 degrees ma' xulxin. U għalfejn dik hija importanti ħafna lina. Għax if we take note of, say, this triangle, per eżempju, hemmhekk x'għandna, jekk ikolli nerġa' npenġiha dik it-triangle. Dik it-triangle għandek id-diagonal huwa l-istess daqs, mela dan id-diagonal huwa l-istess daqs dan. Alright, so given that they've got the same size and they're at the same angle, dak nista' nagħtih il-symbol R. Okay, nista' ngħid dak huwa equal għal resultant. Għandu l-istess angle u għandu l-istess size. Dan is-sajda u isfel, alright, u dan is-sajd ta' triangle huma wkoll indaqs u qegħdin fl-istess direction. Okay? So dan jiena nista' nillejbiljah fit-triangle bħala fx. This other side is equal to this in size. Huwa vertikali wkoll. Mela this I can label as being, għalla ma nagħmilx fin-note, fy. Mela krejna triangle fej sizes ta' sides tagħhom u l-angles li għandna hawnhekk huma l-istess bħal vectors li għandna fid-diagram fejn għandna mpiġġin il-components u r-resultant. Mela x'nistgħu nagħmlu, għalfejn ħanqogħdu nagħmlu da kollu in terms ta' physics. Li ħanibdew nagħmlu hija illi meta niltaqgħu ma' diagonal force xi ħaġa bħal midin, all right? Niftħuha into two components, or rather the proper term would be to resolve into two components. Għalfejn, meta niftħu għal żewġ components li huma 90 degrees ma' xulxin, basically li qegħdin nagħmlu qisnet nagħmlu żewġ sides ta' triangle. Fejn mbagħad il-hypotenuse tagħha dik it-triangle ikun il-resultant vector tagħna. Okay? X'vantaġġ fiha? Il-vantaġġ huwa li issa nistgħu nibdew naħdmu b'90 degree triangles, right angle triangles, u allura nistgħu napplikaw trigonometry kollu li tgħallimtu mill-low level u anke Pythagoras theorem għalihom daw. So, skużawni, if we've got say an unknown side, an unknown value for a force, jekk hijiex ir-resultant jew jekk hijiex f along the y-axis or if it's f along the x-axis, ma tagħmilx differenza, imma nistgħu naħdmu Pythagoras theorem or bit-trigonometry, għax ovvjament sa nkunu nafu jew irridu nsibu għal tal-argument angle. Jiena bħala note, f'dal każ tajkom xi ħaġa għattilkom that the force fed by the ship will be equal to r. And its motion will be due to this force. So basically, qegħdin ngħidu li dan il-vapur sa jkun qiegħed jimxi along that resultant force there. This is referred to as the resultant due to it being the result of the two forces Fx and Fy, bħalma labelina fid-diagram. When quoting R, since it is a force and therefore a vector, one must not only quote its size, but also its direction, li hija l-angle f'dak il-każ. The direction at which it is acting. We can quote any angle we like as long as it indicates the proper direction. In this example, we quote the angle to the horizontal as is indicated by theta on the diagram. So biex naqblu man note, we actually do need to label this as being theta. Okay? That is the angle which is said to be to the horizontal. Taraw għedat misman horizontal. Kieku jiena tajt din tita, dikon najt li hija l-angle to the vertical, edha tmistu mal-vertical. Però ħan il-labeljaw, rather tatux każ din, ħan il-labeljaw just tita u taħt to the horizontal. If fx and fy were to be equal and acting exactly at 90 degrees to each other, then theta would be very clearly dik tkun eżatt in-nofs tagħhom, so dik hemmhekk f'dak il-każ tkun ilna the 45 degrees. Okay? Anyway, so to recap all of this, please, before we go on to the next part of the topic, which deals with components and resolving of vectors, din u din huma components, huma forces that make up the resultant, so they are referred to as components. Tagħmel ħafna sens illi meta jkollok diagonal force niftħuha into two components li huma 90 degrees ma' xulxin. Għalfejn ħalli jekk inti jkollok right angle triangle bħal manna hawnhekk aħna nkunu nistgħu naħdmu bit-trigonometry li jimdorin naħdmu biha mill-low level u Pythagoras theorem li wkoll imdorin naħdmu ħafna biha mill-low level. Ħalli ma jkollniex affarijiet calculations rather tqal bil naħdmu bihom. Il-vantaġġ li nużaw calculation nerġa' nirrepeti huwa li meta taħdem bihom dawn b'calculator tista' toħroġ up to, I don't know, an infinite amount of decimal places jekk trid. Okay? Something which with a grid you can't. As with a grid you need to stick to the size of the actual specific square sizes li inti għandek dik il-grid partikolari. Okay? On to the next.